Alright, so I increased the power output with my transistors here. They're still BJTs, but they are 30 amp ones times 4. It still gets pretty hot though. This resistor down here gets pretty dang hot, so I got a fan blowing through here. Just runs on 12 volt. Well, it's a 5 volt fan, but this is just a 5 volt DC to DC converter. But we'll get that turned on. And this is a 40 watt. Can't even read it. It's a 40 watt incandescent bulb. So we're actually starting to get quite a bit of power output now with this more of the BJT transistors. And I'm noticing lots of ozone, which is kind of, I know it's not good to breathe in, but like it's creating some pretty high voltage that it's able to break down oxygen. And I notice it mostly comes from the center. I don't really notice nothing out here, but I can definitely smell it in there. Like, it's strong. It's making a lot. But yeah, well, I'll keep this. I just don't want to break the bulb, but I'll put this here. So the fan's running. It's gonna help keep these cool. Got a diode that prevent flyback, and just some big beefy rails, and it just got some aluminum bars busting all these batteries together. And this is at 12 volts. I'm gonna make my camera a little wider. Right here, perfect. Ultra wide. So this is at 12 volts. Not too much light. It doesn't generate really any ozone at this voltage, but I notice it around like 24 volts. This output gets quite a bit higher. And then 36 volts, even brighter. And then at the end, 48 volts. And this is when you really can start telling the ozone generation from the coil. And you can definitely tell it's from the center. It's concentrated in the center. Right now it's kind of stuck in there, but yeah, it's safe to touch. It's not really going to do anything with me in the insulation. But these transistors get hot. I mean, they're not hot yet, but it takes a little bit at 48 volts for it to get hot. But these are just inefficient. I need to start working on a MOSFET way of doing this, but that gets super hot, that resistor. I thermally glued it to this heatsink, but it still gets super hot. Yeah, I mean these aren't doing too bad. Well, yeah, now they're getting hot now. Almost too hot to touch, which I'm gonna unplug that. But yeah, definitely some progress with that. You can kind of smell the ozone. And obviously when the light bulb's not plugged in, it generates way more ozone than with it unplugged, because there's no, I think it's because it's dropping the voltage down, so it's not doing as much. But yeah, it's producing a lot more power than what it did before. And I will show you the 200 watt light bulb I can do with that. So this is that 200 watt light bulb that I had before. This is that same 200 watt light bulb. And I'll plug that into here and I'll show you it actually can power this quite well. really should get this thing in there so I can see what kind of power output we're getting, but it's kind of hard with the way this is right now. But yeah, I'll show you. This will be I'll show you each step. So here's 12 volts. It's ringing. Not enough to really do anything. 24 volts. It's ringing. Just enough to start turning the light bulb on. 36 volts. Now it's starting to actually heat up and get a little light. And then for the end, 48 volts. It actually does a decent amount. But yeah, these just, it's cold now after letting the fan cool it, but it heats up so fast. I just don't like this. BJTs they're nice because you don't have to have any like gate drivers or anything, and I'm still trying to figure out how to work a gate driver, and it's quite challenging for me. I don't know why I can't understand it. I do have some gate drivers, and I need to figure out how exactly the internal LED turns on and turns off, and the signal output, if I can use a signal generator, or do I use I thought of using like a small little coil to trigger the gate on the MOSFET, because here I have a setup here where, it's MOSFET transistor, I don't remember exactly what amperage it is, I think it's like a 50 amp or something, and 100 volt I think, or something like that, but I got a bleed diode between, that's a 15 kilo ohm, but like if I touch the wire, no, wrong one. I gotta plug it in. Alright, so, whoop, that wasn't good. You just saw that. I plugged the wrong side on. Oh shit, hopefully I didn't freaking burn it out. Hey, it still works, no way! It still freaking works. Wow. You see how hot that got? It still freaking works. Alright, so yeah. I gotta figure out how to have a MOSFET drive the coils, because they're just so much more efficient. They don't get hot as like these BJTs would. But yeah, I don't know. I gotta figure this out. It'd be great. And for some reason, I put one of my MOSFETs in a circuit, and it drove this for about 10 seconds. It oscillated and made a ton of ozone. I could tell it was creating a ton of power, but it burned itself out. Didn't last very long, and then I couldn't get anything else to work after that, and I literally had it set up just like this. It was no different than this. So why did those MOSFETs work for a little bit, and then no other MOSFET that I tried worked? It just either burned them out or it just didn't work. And I know it's because MOSFETs need to be turned on and off with the positive and negative input, from heat, just I gotta connect positive and then drain it, or keep switching from positive to negative. And that's what the gate driver is for. But yeah, I gotta sit and figure out how to actually do that. And some of the circuitry you see online are just doesn't make sense to me. But yeah, I'm still new to all this, so I got a lot to learn. But so far we're having some improvements with the coil and the circuitry. Well, yeah, I guess I'll cut it off here. I do actually have a coil that I got from someone on Etsy, where it's actually like the correct amount of turns, but it's so thin of wire that it doesn't really make much energy, where my coil is 18 gauge versus I don't know, maybe 24. It's thin. I don't know, too thin for what I want, unfortunately, but I'll probably make something out of it at some point. Alright, now I'll call this. It is it.